Assalamu alaikum. Welcome to this tutorial. In this tutorial I am going to teach you how to model a short transmission line in MATLAB Simulink software. I have taken an example from the book Power System Analysis by Hadi Sadat, chapter 5, example 5.1 as shown here. According to this example, a 220 kV 60 Hz 3-phase transmission line is 40 km long. The resistance per phase is 0.15 ohm per kilometer and the inductance per phase is 1.3263 millihenry per kilometer. The shunt capacitance is negligible. Use the short line model to find the voltage and power at the sending end, the voltage regulation and efficiency when the line is supplying a 3-phase load of 381 MVA at 0.8 power factor lagging at 220 kV. The mathematical solution of this example can be found in the Hadi Sadat book. For your convenience, I have uploaded the example solution in the form of PDF link in the description section. You can download it from there. Now I am going to model the short transmission line in MATLAB Simulink. Just double click on MATLAB icon to open it. At this stage I want to share that while working in MATLAB you need lot of patience, as it is very heavy software, therefore it takes lot of time to start. Now click on Simulink icon to open it. In this window click on this icon to open a new model. First we need to save it. You may save it with any name of your choice and in any folder. To design the transmission line model, first we need a grid or voltage source. To get this, go to Simulink library and go to SimEscape. Click on Power System. Click on Specialized Technology. Now click on Fundamental Blocks, then on Electrical Source. You can see here 3-phase source block is available. Just right click on this block and click on Add Block to Model. It will appear here. Just double click on it, a window will open. We have to put the values. It asks phase to phase RMS voltage, which is sending end line voltage in this case. The sending end line voltage as calculated is 250 kV. Therefore, put 250 kV here. Put phase angle to 0 and frequency to 60 Hz as given in the example data. As we are not going to perform short circuit analysis, therefore uncheck this internal resistance icon. Click on the load flow and if it is swing then keep it same, otherwise change it to swing and click on OK. Now we have to measure the sending end voltage and current, so we need 3-phase measurement block which will be available here. Just right click on it and click on Add to your model. It will appear here. Connect it with 3-phase source. Just click here and delete this 3-phase measurement and write sending end measurement here. Now double click on it, a window will open. It shows that voltage measurement is phase to ground. Keep it same. And it asks about current measurement. As we also want to calculate the current, so keep it yes and click OK. Now we need transmission line. For this purpose 3-phase RLC series branch can be used to represent the short transmission line. To get this 3-phase series RLC branch, go to Simulink library and follow the same procedure. You can see 3-phase series RLC branch here. Bring it to the model and connect it. Now double click on it, a window will open. Branch type shows you the various types of RLC branch. We need RL type because short transmission line consists of resistance and inductance only. From the example, the resistance of the transmission line is given 6 ohm and inductance of the transmission line is given 0.053052 Henry. Now put these values in the transmission block and click OK. Now we again need 3-phase measurement block to measure voltage and current at the receiving end station. Just copy this block by right clicking on it and select copy, and then paste it where you want and connect it with the transmission line. Change the name to receiving end measurement. Now we need 3-phase load block to put the load values, which is available here. You can rotate it by pressing Ctrl+R to change its direction in order to connect it with other components. Now double click on it, a window will open. We have to put the values for receiving end voltage, frequency and other parameter of the load. The receiving end voltage is 220 kV and frequency is 60 Hz as shown in the example. Now put the receiving end active and reactive power of the load as shown here, and put capacitive reactive power to 0 because our load is inductive. We need to connect the measurement block to display so that voltage and current measurement can be seen. Before this, it may be noted that meters usually measure RMS voltage. Therefore, first we need RMS block to convert this AC peak voltage into RMS voltage. Take this RMS block and put it in the model and connect it with the 3-phase measurement block. Now connect display with it to measure the voltage. Now double click on the RMS block and change the initial RMS value to 0 and press OK. For current measurement, just copy the RMS block by pressing Ctrl+C and pasting it here by pressing Ctrl+V. Repeat the same procedure for display too and connect it. Delete the word display and write sending end current and sending end voltage. Now I think we can run the simulation to see the measurement on sending end side. Before running the simulation, we need power GUI block to run it. Otherwise it will give error. To get this block, just write it in search term of Simulink library and enter. It will show the power GUI block. Copy this block and paste it in your model. Set the simulation time to 1 second. Now you can run the simulation. It is giving 3 measurements due to the reason that we are measuring all 3-phase voltages and currents. You can compare the results with the example results. You can see both are correct. Now we need to measure the sending end active and reactive power. For this purpose, we need 3-phase power instantaneous block. Take this block and put it in the model and connect it with the RMS voltage and current measurement wires. Now connect the display with the P and Q icon in order to measure the active and reactive power. Write down here QS as sending end reactive power and PS as sending end active power. Now you can run the simulation and compare the answer with the answer obtained in the example. You can see both answers are correct. Now we have to measure apparent power at the sending end side. We know that S is equal to V into I. So for this purpose we need product block to multiply V and I. And then we need a summer block. And now connect the display to measure the apparent power at sending end side. Write here S is equal to V into I. And here S is equal to 3 into V into I because it is measuring all 3-phase voltages and currents. And write here sending end apparent power. Now you can run the simulation and compare the answer with the answer obtained in the example. You can see both answers are correct. Now we have to perform all these voltage, current, power measurement at the receiving end side. Therefore, an easy way is to copy all these model and paste it here and connect it with the blocks in order to avoid the repetition and save the time. Now you can run the simulation and compare the answer with the answer obtained in the example. You can see both answers are correct. Replace the sending end with receiving end voltage and current, receiving end active power and reactive power. Similarly, receiving end apparent power. Now we need to measure the voltage regulation of the transmission line. Mathematical formula for percentage voltage regulation is given here. We know that 3-phase measurement block is giving 3 voltages and 3 currents measurements, and 1 measurement is sufficient for the calculation purpose. Therefore, we need demultiplexer to convert these 3 readings into 1. Now we need a subtract block. Put the same demultiplexer block with the receiving end voltage. Now connect both sending end and receiving end voltage measurements with the subtraction block. Now we use divide block, and to multiply it with 100 we need a gain block. Put the value of the gain from 1 to 100. And connect the display for measurement. Now you can run the simulation and compare the answer with the answer obtained in the example. You can see both answers are correct. Change the name percentage voltage regulation. Now we are going to perform the transmission efficiency given by the PR upon PS into 100. Take the divide block, copy and paste here. Connect it with the receiving end active power. Divide it with the sending end active power. Multiply it with 100 by using the gain and connect it with the display for measurement. Change the display name to transmission efficiency. Now you can run the simulation and compare the answer with the answer obtained in the example. You can see both answers are correct. At this stage, we have modeled short transmission line in MATLAB Simulink software. In this tutorial, I have discussed how to design short transmission line in MATLAB Simulink software, and I have discussed how to measure the voltages, current, active, reactive and apparent power at both sending end and receiving end stations. And I have discussed how to measure the voltage regulation and transmission efficiency in the MATLAB Simulink. That's all in today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.